Hello and welcome to Maths with el Profe Lo. I'm going to do some exam style questions in this video. So we're going to look to prove that the product of three consecutive integers is never a perfect power. Alright, so meaning it's never going to be something, a number squared or an integer squared. Never going to be an integer cubed, an integer to the fourth power, right? That if I have three consecutive integers and I multiply them together, never going to get a perfect square. Okay, so let my integer, right? Let the integer product be n minus 1 times n plus 1, which would give us n squared minus 1 times n. Correct? I believe that's right. So n minus 1 times n plus 1 would be a product of three consecutive integers, and we know that's going to be n squared minus 1 times n. Okay? Now, n squared minus 1 and n are necessarily relatively prime. Right? N squared minus 1 and n are necessarily relatively prime because the only number that would divide n squared minus 1 and n would have to be 1. Okay? The reason being, of course, is that if I have a remainder of 1 left over, then we see that n squared minus 1, when on division by n, will have negative 1 left over. Okay, so we also know by the fundamental theorem of arithmetic we also know by the fundamental theorem of arithmetic that n squared minus 1 is a perfect kth power, where k is greater than or equal to 2, and n is also a perfect kth power. Right? However, n squared minus 1 and n squared cannot be consecutive perfect kth powers. Alright, so even though n squared is a perfect power, and n squared minus 1 can be a perfect power, I cannot have n squared and n squared minus 1 be perfect powers consecutively. Okay, and because of that, the product of three consecutive integers is never a perfect power. Okay? As you have questions, please reach out. This has been Maths with el Profe Lo.